So in the last class, we end up here that the general equations are this for the addition reactions of alkenes with hydrogen halide, such as hydrogen bromide, and with a halogen such as chlorine. So carbon-carbon double bond is converted into carbon-carbon single bond, and at one carbon we have one chlorine, and at another carbon we have another chlorine. Since it is symmetrical, so we can add any chlorine atom to any carbon. Next is addition of hydrogen H2. So this also double bond is getting converted into single bond, and in one carbon you have hydrogen, and in one carbon you have another hydrogen. So when hydrogen gas and an alkene, they are heated over and passed over a finely divided platinum or nickel catalyst. So which catalyst is required for the hydrogenation of alkenes? This is known as hydrogenation of alkenes. That means addition of hydrogen to the alkene. So addition reaction takes place. Addition reaction means we already covered in the last chapter that two or more molecules combine to give a single product. So we have ethene, C2, H2, H4 plus hydrogen. So what happens? Carbon-carbon double bond is converted into carbon-carbon single bond. At the first carbon we have one hydrogen, and at the second carbon we have another hydrogen. So ethene is converted into ethane. So this addition reaction of alkenes is known as hydrogenation. That means addition of hydrogen. This takes place only in the presence of platinum or nickel catalyst. It is used in the manufacture of margarine. Margarine is this butter. So unsaturated oils such as sunflower oil contain hydrocarbon chains. Unsaturated means there should be one carbon-carbon double bond present or one carbon triple bond present. So these oils become partially saturated by reacting them with hydrogen. It straightens the hydrocarbon chain. This raises the melting point of the oil, and it changes them from liquids to soft solids that can be spread easily, which is spread it on the bread. So this is the application of this reaction. That means vegetable oil is converted into vegetable ghee or margarine. Butter, it gets converted to a solid which is having a higher melting point, and it can be spread easily on the bread. So this sunflower oil is your vegetable oil, which is unsaturated. What happens when we add hydrogen? We get a saturated compound, which is also known as your margarine or vegetable ghee. In next reaction is addition of hydrogen halide. Addition of hydrogen halide. Hydrogen halides like HCl, HBr. So what happens? See, when an alkene is, this reaction is very important. So look at this carefully. That when an alkene is bubbled to a concentrated solution of hydrogen halide at room temperature, product is a halogenoalkane. That means an alkane in which a halogen is replaced, in which hydrogen is replaced with a halogen. So this is ethene. When HBr reacts with it, then we get bromoethane. With longer asymmetric alkenes, there are always two possible products that could be formed. So this is symmetrical, right? So at any carbon you can add H, at any carbon you can add Br because this is symmetrical. But look at this example with propene. This is not symmetrical. So at which carbon you should add bromine? Carbon number 1 or carbon number 2? Okay. At which carbon you should add bromine? If I add bromine on second carbon, I get 1 bromopropane. If I add bromine to the first carbon atom, then I get 2 bromopropane. So these two are different products. Okay. So where two addition products are possible, major product it is the one which has the halogen atom bonded to the C double bond C carbon atom with the highest number of alkyl groups bonded to it. Okay, so major product in this case is this one. Okay, so in this example, you have a rule that is known as Markovnikov rule. Markovnikov rule to tell us which is the major product. 1 is the major product or 2 is the major product. Okay, so it states that the negative part will attach to that carbon atom which have here in HBr, which is the negative part, H or Br? Tell me.
Br.
Yes, Br is the negative part. So the negative part, it will attack to that carbon atom which have less number of hydrogens. So less number of hydrogen is at the first carbon or second carbon? At the first carbon. So when the Br is attached to the first carbon, it would be the major product. So that's why we can say that the second one is the major product. So today what we had discussed, we have discussed the addition of hydrogen. Take a screenshot of this. This is very easy. You have to just add hydrogen and convert the double bond carbon to carbon single bond carbon. This reaction is known as hydrogenation of alkenes. Okay. This is the application of this reaction. Vegetable oil, when we add hydrogen to it, it gets converted into, it solidifies, it's converted into vegetable ghee or margarine. Done. This I am just explaining addition of hydrogen halides. So in the first reaction, you can see that this is the symmetrical alkene. So at any carbon add H, at any carbon attach Br. But in the asymmetrical alkenes, you have to follow this rule which is known as Markovnikov rule. Negative part will attach to that carbon atom which have less number of hydrogen. So less number of hydrogen means you have to consider only alkene. This one. So CH have less number of hydrogen. So the negative part, that means Br, it will attach to this. So major product would be second one. 2-bromopropane. Okay. So when two addition products are possible, major product is one that has the halogen atom bonded to the C double bond C carbon atom with the highest number of alkyl groups bonded to it. That means which is the most substituted. In this case, if we see, so this is my alkene. So this carbon number 1 is most substituted because it has a methyl group. While carbon number 2 is having only 2 lighter hydrogens. So bromine will attach to the carbon number 1. So this is nothing. This is your Markovnikov's rule.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Now, in the two reactions of propene with HBr shown, the bromine bonds to the central carbon atom to form the major product. Okay, so just understand each and every line that the central carbon atom has 2 alkyl groups bonded to it compared with the single ethyl group on the end carbon atom. Therefore, this is the major product. So remember that each alkyl group, it tends to donate electron along its positive bond to the positively charged carbon atom in the carbocation. So this is formed from a secondary carbocation intermediate, that is CH3, CH. Here we have a carbocation on which the bromine is attached, CH3. This is a carbocation intermediate. It is more stable than a primary carbocation. Primary carbocation means this one, CH3, CH2, CH2 plus. Primary carbocation means the carbocation which is attached to one carbon, it is called 1-degree carbocation, which is less stable. Okay, and the carbon which is attached to 2 carbons, it is called the 2-degree carbocation. This is more stable. So if this is more stable, that's why bromine has reacted here. So positive charge becomes less concentrated by the inductive effects of 2 alkyl groups, because CH3 group, it shows inductive effect. That means electrons, they are donating to this electron deficient molecule from 2 sides. That's why it is more stable as compared to only one alkyl group. So therefore, secondary carbocation intermediate is more readily formed in the course of this addition reaction. So in this reaction, your secondary carbocation is formed in which bromine attached. Bromine is a nucleophile, which is electron rich. So it attaches to the electron deficient carbocation. So read it. If there's any problem in any line, please let me know. So what is the mechanism, the electrophilic addition which follows this? First of all, carbocation formation occur. which is then attacked by a negative ion, and the final step is final product of the addition reaction. So first of all, there is the formation of carbocation. Then it is attacked by a negative ion because carbocation is positive, and that's why it is attached to a negative ion. And then we have a final product of the addition reaction. So we will see in both the products, we get two products. So we will see which is more stable carbocation. In first part, we get 1 degree, and in the second reaction, we get 2 degree carbocation. This one is more stable, so this one is your major product. Okay, so this is a mechanism for the electrophilic addition of HBr to propylene. So as you know that bromine is partially negative, hydrogen is partially positive. So what happens is a formation of carbocation. This bond, it will attach to this hydrogen. Why? Because this is electron rich, it will attach to this electron partially positive charge. Okay, so we have a carbocation formation occurs at this carbon, and then we have bond. Okay, so it is very simple. CH3CH double bond CH2. When HBr attaches to this, then this bond it gets transferred to here, and this HBr bond gets transferred to here. So we have CH3 CH CH2H. Then at this position, since the double bond is getting converted to a single bond, so at this position we are having a carbocation. And at this carbocation, the bromine which leaves from here in this step with the lone pairs, it will attack to this carbocation, and the formation of 2-bromopropane will occur, which is the major product. So this is a secondary carbocation forms, and it is attacked by the bromide ion. So we have to make the most stable carbocation here. That's why hydrogen gets attached to this carbon, so that we have a 2 degree carbocation here. Okay, so next reaction is addition of steam. Steam, that is H2O in the gaseous state. So scientists in industry use the addition of steam to alkenes to make alcohols. They react steam and the gaseous alkene, high temperature and pressure, in the presence of concentrated phosphoric acid as the catalyst. H3PO4 is the catalyst. When the alkene is ethene, product is ethanol. However, the ethanol found in alcoholic drinks is always produced by the fermentation of glucose. Ethanol is produced by the fermentation of glucose. Like say this reaction, this is my ethene. When you add H2O in the gaseous state here in the presence of phosphoric acid as the catalyst, since it is symmetrical, so at any carbon you can add H, and at any carbon you can add OH, because H2O is what? It is H plus and OH minus. Okay, so we get the ethanol. So ethene plus steam in the presence of concentrated phosphoric acid, we get ethanol. Okay, now when bromine is attached to alkene, then at one carbon you have bromine, and another carbon you have bromine, since it is symmetrical. So at any carbon add bromine, at any carbon add bromine. So we get 1, 2 dibromoethane. The reactant chlorine, it is a very pale green solution which is called chlorine water. Bromine water is orange or yellow. It depends on the concentration of bromine water. Bromine water is used to test for the presence of carbon-carbon double bond in compounds. The compound to be tested, it is shaken with bromine water, and if it is unsaturated, that means if it contains a double bond or a triple bond, then the color of bromine water, which is orange or yellow in the starting, it will be decolorized. So we can easily test the presence of unsaturated compound in our organic compound. This test is known as bromine water test. Okay. See here, addition reaction happens. It is used to test for an unsaturated compound. So our organic compounds contain double bond or triple bond. So the orange red color of your bromine, it gets decolorized. So we can say that in our organic compound, a double bond or triple bond is present. That means it is unsaturated. Next is a mechanism of electrophilic addition to alkenes. So the double bond in ethene, it is formed from a 1 sigma bond and 1 pi bond. How many electrons are there in this double bond? 4. 1, 2, 3, 4. And it is a non-polar molecule because carbon-carbon bonds, the same electronegative atoms are attached to it. So it is a non-polar molecule. There is an area of high electron density around the C double bond, C bond. So this makes the alkenes open to attack by electrophiles. Electrophiles are electron deficient, which can easily attack to electron-rich carbon-carbon double bond. Remember that an electrophile is an acceptor of a pair of electrons because it is electron deficient. HBr, it is a polar molecule because of difference in electronegativity between hydrogen and bromine atom. In a molecule of HBr, hydrogen atom carries partial positive charge and bromine atom carries partial negative charge. So in the mechanism of addition reaction, the hydrogen atom, it acts as the electrophile which accepts a pair of electrons from this double bond in the alkene. But how can a non-polar molecule such as bromine, it can act as an electrophile? It is not positively charged. So how it is an electrophile? So as the bromine molecule and ethene molecules approach each other, area of high electron density around this carbon-carbon double bond, it repels the pair of electrons in the Br-Br bond away from the nearer bromine atom, which makes the nearer bromine atom slightly positive and the further bromine atom slightly negative. So the partial charges are developed here. So this is the mechanism of electrophilic addition to the alkenes.